The most likely thing you are, according to some of the best physics we have, is a brain that assembled itself out of empty space a few seconds ago, complete with a lifetime of memories that never happened. Not a metaphor, an actual, calculable, published conclusion that serious cosmologists have been arguing about for decades. And here's the concrete, horrible little detail that makes it stick. Under this idea, a brain floating alone in the dark, hallucinating an entire life, is vastly more likely to pop into existence than a whole universe like ours. The cosmos, statistically, would rather make you than make everything around you. Stick around, because the way physicists finally escaped this nightmare is stranger than the nightmare itself. Now, before you throw your phone across the room, let's be clear about something. Nobody actually thinks you're a floating brain. The point of this idea is far weirder and far more useful than that. But to understand why, you have to meet the man who accidentally opened the door, and then watch the entire field of cosmology spend a century trying to shove it closed. His name was Ludwig Boltzmann, and he was Austrian, brilliant, and deeply unpopular. In the late 1800s, Boltzmann was trying to explain something that sounds obvious until you actually think about it. Why does everything fall apart? Drop a glass, it shatters. It never unshatters. Your coffee goes cold. It never spontaneously reheats itself by stealing warmth back out of the room. Your room gets messy on its own, and it has never once tidied itself while you were out. There is a direction to time, and it points downhill toward mess. Boltzmann gave that mess a name and a number. He called it entropy, and entropy is basically a measure of how many ways you can rearrange something without anyone noticing. Think about it. There's exactly one arrangement of a perfectly stacked deck of cards, but there are an astronomical number of arrangements that count as shuffled. So when you shuffle a deck, you don't get order because order is rare and mess is everywhere. Mess isn't a force. Mess is just a numbers game, and the numbers are absolutely enormous. That's it. That's the second law of thermodynamics, which Boltzmann carved into physics forever, and which is now literally carved onto his gravestone in Vienna. Entropy goes up. Things get messy, eh? The universe is a room that never tidies itself. So Boltzmann should have been a hero, right? He was not. His colleagues mocked him because his whole theory depended on atoms, and a loud group of respected scientists insisted atoms were convenient fiction that didn't really exist. Two of them in particular made his life difficult. A physicist named Joseph Loschmidt pointed out that the laws of physics work the same forwards and backwards. So where does the downhill direction even come from? And a mathematician named Ernst Zermelo, armed with a theorem from Henri Poincaré, pointed out something even nastier. Any closed system, given enough time, will eventually wander back to almost exactly where it started. Wait long enough, and the shuffled deck reshuffles itself into perfect order. Wait long enough, and your cold coffee gets warm again. Boltzmann died in 1906, before the world fully admitted he'd been right about atoms all along. It's one of the sadder footnotes in physics. But before he went, he tried to answer his critics, and that answer is where our monster is born. Because Boltzmann had a genuine problem. If entropy always increases, and the universe is old, then everything should already be a lukewarm, featureless soup. Total mess. Maximum shuffle. So why are you looking at stars? Why are there galaxies and planets, and a functioning brain reading this sentence? Why is the universe so suspiciously, gorgeously tidy? And Boltzmann said, more or less, maybe it isn't. Maybe the universe as a whole is a lukewarm dead soup, exactly as expected, and we just happen to be sitting inside a freak accident. Because here's the thing about randomness. If you wait long enough, random jiggling doesn't just produce mess. It produces everything, every arrangement, including, occasionally, order. Shuffle a deck for eternity and you will, eventually, get a perfect suit-by-suit stack. Not because shuffling wants order, but because eternity is time for absolutely everything. So maybe our entire ordered cosmos is a bubble of accidental tidiness that burped out of an infinite Dead Sea. We only see order because we couldn't exist in the parts that don't have any. It's a genuinely clever escape. Do you see the trapdoor he just stepped on? Because if the universe can randomly fluctuate a low-entropy bubble into existence, the obvious next question is, how big a bubble? And that question has a deeply upsetting answer. Making an entire universe by accident is expensive. You need billions of galaxies, all the stars inside them, 13.8 billion years of consistent history, the works. That is a staggering amount of order to get for free. It's like asking a hurricane to build a city. But what if the fluctuation only had to make less? What is the smallest thing that could possibly be having your experience right this second? Not your house, not the earth, not the sun. Just a brain. A single functioning brain with a set of memories baked in, having one moment of conscious experience, including the experience of seeing a room and remembering a childhood and feeling completely certain that all of it is real. That is dramatically, unimaginably cheaper than a universe. Fewer particles, less order, less luck. And here's the line that should keep you up tonight. A whole universe is expensive, and a brain is cheap. And randomness, given eternity, always buys the cheap thing far more often. So if you take Boltzmann's escape seriously, it doesn't predict a cosmos full of people like you. It predicts a cosmos that is overwhelmingly, catastrophically dominated by lonely brains flickering into existence in the dark, each one convinced it has a past, each one dissolving moments later back into nothing. For every real observer, there would be an unthinkable number of fakes, and you have no way to check which one you are. That's the Boltzmann brain. And it would be a fun little party trick, a spooky philosophy class thought experiment, if modern physics hadn't quietly made the whole thing much, much worse. Because here's the part people don't expect. This isn't a 19th century ghost story. In the last few decades, our best models of the cosmos have been actively feeding the monster. Remember dark energy, the mysterious pressure that is pushing the universe apart faster and faster? If it keeps behaving the way it does now, the universe doesn't end with a bang. It ends by stretching out into an eternal, freezing, nearly empty expanse. Everything burns out. Every star dies. And then, nothing happens. For a very, very long time. Forever, in fact. But empty, in physics, is never truly empty. That far future universe still has a whisper of temperature and a permanent quantum fizz, space itself twitching, forever, with random fluctuations. And what do random fluctuations do if you give them infinite time? They build things. Rarely. Absurdly rarely. But infinity does not care how rare something is. Infinity only cares whether it is possible. Physicists have actually run these numbers. Cosmologists like Andreas Albrecht and Lorenzo Sorbo dragged this problem into the modern era in the early 2000s, and the physicist on page took it seriously enough to work out timescales. The waiting time for a random brain to assemble out of nothing is a number so large it breaks normal notation. Think of 1 followed by more zeros than there are atoms in the observable universe. Ludicrous, preposterous, and completely irrelevant if the universe lasts forever. Because ludicrously rare multiplied by infinite time equals happens constantly. Then it gets worse. Our leading theory of the universe's birth, called eternal inflation, championed by physicists like Alan Guth and Andre Linde, suggests that space keeps sprouting new regions endlessly, producing not one universe, but a limitless number of them. Which sounds beautiful until you realize it hands the Boltzmann brains an infinite factory. Now you're not just outnumbered. You're outnumbered infinitely. And this creates a genuinely unsolved headache in cosmology called the measure problem, which is exactly the nightmare it sounds like. When you have infinitely many of everything, how do you even do statistics? How do you say one outcome is more likely when all the counts are infinite? Nobody has a fully accepted answer to this. Cosmologists are still arguing. Right now. Today. So let's actually sit in it for a second, because this is where the idea gets under your skin. If you were a Boltzmann brain, what would it feel like? It would feel exactly like this. That's the whole problem. You'd feel a body you don't have. You'd remember a breakfast you never ate. You'd be certain about a childhood that never occurred. Your memory of yesterday isn't evidence that yesterday happened. It's just a physical pattern sitting in your head right now, and a random fluctuation could have baked that pattern in from scratch. Every proof you have of your own past is stored in the present. Every single one. And it would be brief. Naked brains do not do well in the vacuum of space. You would flicker into being, have one confused thought about dark matter in a YouTube video, and be gone before you finished it. Cheerful stuff. So how on earth do we get out of this? Here's the twist, and it's beautiful, because the escape isn't a physics result. It's a logic result. The argument commits suicide. Watch what happens. Suppose you conclude, from the evidence, that you're almost certainly a Boltzmann brain. Fine. But if you're a Boltzmann brain, then your memories are random noise. Your knowledge of physics? Random noise. The equations you use to reach this conclusion? Noise. The data about dark energy, the entire history of science, your confidence that entropy even works that way, all of it, junk, hallucinated a second ago by a fluctuation that had no interest in being accurate. Which means you have just used unreliable reasoning to prove that your reasoning is unreliable. The conclusion destroys the evidence for the conclusion. It's a snake eating its own tail. The physicist Sean Carroll has a good name for this. He calls such theories cognitively unstable. They cut off the branch they're sitting on. You literally cannot coherently believe you're a Boltzmann brain, because believing it means you have no grounds to believe anything. And once you see that, everything flips. Boltzmann brains stop being a horror story about you and start being something much more useful, a bug detector. Because now they're a test. If you build a model of the universe and you run the numbers, and your model predicts that most observers in it are random brains rather than real people, your model is not revealing a terrible truth. Your model is broken. It just failed. Throw it out. Boltzmann brains are the smoke alarm of cosmology, and every time a theory sets one off, physicists know something in that theory is wrong. That's exactly how they're used today. Don Page, for instance, suggested that the universe might have to decay or end before the brains get a chance to dominate, turning how long can our universe last into a question that Boltzmann brains help constrain. A ghost from 1890 is now doing real work, ruling out theories about the fate of everything. So let's come back to you. You're not a brain in the void. And the proof isn't a formula. It's the astonishing, boring consistency of your own life. A Boltzmann brain gets one flickering, incoherent moment. You got a world that keeps making sense. The floor stays where you left it. The people you know keep their names. The physics that worked yesterday works today. Gravity has never once taken the afternoon off. Randomness cannot fake that. Not for a lifetime, not for a second video, not for the next sentence. The universe being understandable, that stubborn, unglamorous fact that things keep adding up, is the strongest evidence you have that any of this is real. Order that keeps holding is not what accidents look like. And that's the real gift Boltzmann left us, even if he never meant to. He asked why the universe is so suspiciously tidy, and the question was so sharp it took 100 years and a monster to answer. The mess in your room is proof that entropy is winning. The fact that the room is still there tomorrow is proof that you are not a hallucination. So the most likely thing you are is not a brain that popped out of empty space. The most likely thing you are is something far more improbable and far more precious, a real observer in a real universe, briefly ordered enough to notice that it's falling apart. But it does raise one uncomfortable question, doesn't it? If your only evidence for your entire past is a pattern sitting in your head right now, how would you ever tell the difference?